Hello and welcome back. Um, welcome back to me as well. It's been a very long hiatus from uploading videos, not just uploading them, making them. Um, yeah, yeah. The steam ran out. The pseudo ADHD said it was time to move on. But I do check on the comments every so often, and I was very thrilled to come across this comment from Flamer Gamer 1235, to whom we owe the next however many videos I'm going to now create and upload. And really just our reminder that ask and you shall receive. I will try. I am even going to go and relearn data handling so that I can make a video specifically for one of the questions that have been requested here. So really, if you would like to see me make a video on a certain question from a paper of interest, I will try. I know this is 6 days later. I had given myself a deadline of, I'm going to try and do it within the week. So technically, I'm still within the time frame. I really hope you weren't writing a test or an exam this week, Flamer Gamer. Otherwise, I do hope that this content will still be helpful in preparation for your exams. Those are still coming up, right? Anyway, so I had actually done videos for IEB May 2024. This is a request for me to add some more. And so that is what I am going to do. I think there are 4 videos that I'm going to do now, and then I'm going to go and teach myself data handling. Those of you who've been with the channel know that me and data handling, I don't think I have ever done a single video on data handling. So that really should just tell you the extent of the love. Or it should excuse me if I just don't find enough momentum to go through with it. Anyway, but I am going to do at least 4 videos to add to the IEB May 2024 Paper 2 series. Without further ado, let us get going with our first video, which will be question 2. Right. I am not using a microphone anymore because, my hiatus actually began while I was busy recording the series for, I think, IEB May 2022. And there were 2 particularly tough questions that I had made like really long, juicy videos for. And as I was just randomly listening, playing them back, I realized that my mic had been bugging. So there were moments where I sounded like a robot. There were moments where I sounded like nothing at all. And I was just devastated that, I'd spent all that time yabbering away. And meanwhile, back at the ranch. And yeah, I pretty much just rage quit at that point. So yeah, me recording now, I'm just like, me and the microphone, we are not on good terms. So unfortunately, what that means is if I make movements, you are going to hear them. I am sorry. I will try to limit the movements. Otherwise, please treat them as ASMR. Thank you. Right, question 2. In the diagram, ABCO is a parallelogram, okay, important, with the vertex O at the origin. Good. Parallelogram, they've so kindly indicated to us that the opposite sides are parallel. We also know that the opposite sides are equal. So those are important things to kind of just hold on to as we go on to this. Point C with coordinates -3 and 6 is given. Nice. The equation AO is given as y is equal to 2/3 x. Okay, and they've labeled it for us, the very kind people at IEB. And then diagonal AC is perpendicular to the x-axis. So in other words, parallel to the y-axis, which means that this is a perfectly vertical line. So that already tells us something about the coordinates of A, right? Okay, good. First question says, determine the equation of BC in the form y is equal to mx plus c. BC, okay. What do we know about BC? We know that BC is parallel to AO because parallelogram things. And so they have the same gradient, which we can find over here in this equation. Y is equal to 2/3 x, the m in y is equal to mx plus c. So this one also has a gradient of 2/3. And then we have a point on the line, which will also then help us find the c. So we are made. Let us... Okay, just need to rotate my iPad because left-handed things. Right, so we know that AO is parallel to BC because opposite sides of a parallelogram are parallel. And so therefore, the gradient of BC is equal to the gradient of AO, which is 2/3. And so therefore, the equation of BC will look something like y is equal to 2/3 x plus c. To find the c, we will then substitute this point. So sub in the point c. So we know that when x is equal to -3, the y coordinate is equal to 6. And then we just solve that. So that will be -2 plus c is equal to 6. And so c is equal to 8. And so all in all, the equation of BC is y is equal to 2/3 x plus 8. And we are going to go ahead and fill that in on our diagram and move forward. Moving forward. Because who knows, we might need this later. Right. And so with that, I take my diagram. And I don't really remember how to do what I want to do, but let's see, that seems to be fine. Come over here, diagram. Thank you. Right, next question. Determine the coordinates of A. Right, and A is that point that we already identified. There's this nice relationship happening between A and C. A is directly below C. So we know that they share an x coordinate. So we know that the x coordinate, the x coordinate of A is equal to the x coordinate of C, which is -3. So that's the first piece of the puzzle. And then we also know that A lies on the line y is equal to 2/3 x. So that will give us the y coordinate if we plonk it in there. So to get the y coordinate of A, we will just work out 2/3 of -3. And that is indeed -2. And so the coordinates of A is -3, -2. So let's go ahead and fold that in on our diagram as well. Oh, Mr. D orders. Stop revealing yourselves. Right. I'll just plonk it underneath here. So -3 and -2. Right. Good. Diagram, come with me. Okay. Right. Next up, determine the equation of AB. AB. So AB What do we know? We have a point on that line. And what do we know about B? I mean, we could find the gradient of AB by finding the gradient of OC, because we know the coordinates of O, it's the origin. And then because they're parallel, I could use that gradient and that point to find the equation of the line. I don't know if there is a more obvious route. Yeah, but I think that's what I am going to go with. Alternatively, I don't know. I think that's what I'm going to go with. So I find the gradient of OC, which will give me the gradient of AB, and then plonk in this point. So pretty much what we did for the first question, I think. But something tells me I'm missing something else. But anyway, an answer is an answer, y'all. Right, so the gradient of OC is difference between the y's, difference between the x's. So that ends up being 6 over -3. By the way, you don't need to do these calculations. You can just write the final answer. Right, so the gradient of CO or OC is -2. And so we know that OC is parallel to AB because opposite sides of parallelogram are parallel. And so therefore the gradient of AB will be the same as the gradient of OC, which will be -2. And so therefore equation of AB will look something like y is equal to -2x plus c, and then we'll sub in the point that we know. So we'll sub in the point A, and so we know that when x is -3, the y is -2. So that is 6 plus c is equal to -2, and so c is -8. Right, and so the equation of AB, I'm just going to shrink these a bit. Will be y is equal to -2x minus 8. Okay, so let's fill that in. Y is equal to -2x minus 8. Right. And then I think we're on to our last question, which says, determine the coordinates of B. Right. So, this is that classic scenario. Does that make sense? But basically we use the fact that these sides are equal and they have the same gradient. So we know that not only is the rise and the run in the same ratio for both of these sides because the gradients are the same, but the rise and the run are exactly equal for both of these sides because they're equal in length. So we expect that, the rise and the run, it makes sense in my head, but but yeah, basically because they're equal in length, we know that not only are the rise and run in the same, not only are they, the same ratio because of the gradients being the same, but because the sides are also equal, we know that the rise and the run are also then exactly equal. So because we know how much we're rising and running, or in fact, maybe it will be better to go from O to A. So rising and running to get from O to A, we know how much we're rising by -2 and then running by -3. So to go from C to B, we'll also need to rise by -2 and run by -3. So the coordinates of B will be 6 minus 2. Oh my goodness, what am I saying? It's because it's the rise first, and the rise is the y. Anyway, so it'll be 6 minus 2. Okay, that'll be the rise. And then the run will be -3 minus 3. Right, so just to kind of write this visually, this is a rise of -2 and then a run of -3. So then we do exactly the same here. So we rise by -2 and then run by -3 to get to B. Right. And so, whoa. That means that the coordinates of B are -6 and 4. And we can double check that this is sane by putting the coordinates in here and seeing if they work. So -2 times -6 is 12, minus 8 is indeed 4. So that's some vote of confidence in our method. What is another way that we could have found the coordinates of B? I guess we could have found the midpoint of, oh my goodness, what just happened? Oh, the midpoint of AC, because that will also be the midpoint of OB, right? That's one of the properties of a parallelogram, is that the diagonals bisect each other. So that means that they both have the same midpoint. And if you then find the midpoint of AC, then, and you know the coordinates of O, so you can then kind of, figure out the coordinates of B that way. Let me know if that's something you'd like me to demonstrate. But yeah, that's another way you could have found the coordinates of B, I guess. And I think that's it for this question. So let's go ahead and mark ourselves. Let's see just how rusty I've gotten on this hiatus. Question two. First up. So I will just comment on methodology if they do something that surprises me. But yeah, otherwise I will just say whether the answer is right or not. In this case, the answer is correct. And our approach is pretty much identical. Right, next up. Next up, yes, we get the same coordinates for A and we also approached it the same way, so that's cool. And then the next question, they do indeed find the gradient of OC, which then gives us the gradient of AB. We then sub in the point A and we get y is equal to -2x minus 8. So that is perfecto. Wow, okay, I thought there was going to be a different aha to it, because it really is quite similar to what we did for the first question. Yeah, I guess maybe the extra element was to work out the gradient as opposed to being given the gradient. In the first question, we're given the gradient, and in this question, we had to work it out. So, I don't know. Anyway, then for the last day, Ian, right, we use symmetry. That's also a very good way of explaining this rise-run thing that I was doing. A parallelogram is symmetric. Yes, I guess it is symmetric. It is symmetric, I guess, if you fold it along this line and if you fold it along this line. So Yeah, it just then makes sense symmetrically. I don't know, visual people. Yeah, anyway, but yes, -6 and 4 are the coordinates. Another way that you could have found it is, of course, to find the point of intersection between these two. Oh my gosh, oh my goodness. So that would have been a bit more of an algebra intensive way, but also a very valid way to go about it. Right, that is that on question 2. Thank you very much for coming to my TED Talk, and maybe I'll catch you on the next question. Bye.